So just a little bit of background. I went through UNE, did a Bachelor of Rural Science, and as part of the Bachelor of Rural Science, we really try and have this production system focus. And so as we go through the talk, you'll notice a couple of different areas where I might not be just talking about genetics, because I'm a geneticist, I love genetics. I'll be talking about how does that fit with the entire production system. And so for the last 2.5 years, we've been travelling around the country trying to record animals for how much methane they're producing over a certain period of time, to help to understand, one, how much energy is lost in the system due to methane, and two, to start to understand, well, is there variation in animal performance? So today I'll talk to you a little bit about why we're recording methane. Of course, as a geneticist, I want to tell you about the role of genetics in methane research, and then what the lessons that we've learnt today. And there's been quite a lot of lessons. One about recording methane in the field, whether it's in the pasture or in a feedlot scenario, but also how can we think about different tools to manage methane in a sense. And I'll also give you a little bit of an update and some early results from our project. So often this slide is portrayed as quite a negative thing for the beef industry. So often people will stand up, like I am today, saying, oh, emissions are a really challenging thing for beef cattle, with 16% of Australia's emissions coming from agriculture, and of those 16%, 77% coming from beef cattle. Now, me personally, I'm not such a fan of the way methane is portrayed in the system, mainly because methane is very different from the emissions that are formed from when you burn a fossil fuel. So if we have a look at this slide, what happens for a cow is essentially they're part of an entire system. They're not digging up coal and burning it or using oil to move the car around. What is happening is we have this essentially a closed system. Cow comes in, eats some pasture, digestion occurs, essentially microbial digestion, and one of the waste products from microbial digestion is methane. That methane goes into the atmosphere and is converted to CO2. On average, about 12 years it takes for that to happen, and then it's actually sucked back in the system. So if you have a continual number of animals, so across the globe, number of ruminants doesn't increase, we don't actually have an increase in emissions. We've just got a standard amount of emissions. Now, often that is a bit challenging to think, oh, well, how have we contributed to the increase? I like to flip it a little bit and say there's a real opportunity for beef production to actually be part of the decrease, actually be a really important part of managing carbon in the cycle. Now, of course, this microphone's a bit of a tricky microphone. Of course, we're actually trying to think of it as a system, and I'll talk more and more about what is available to people. But it's good to think of this one and keep that in the back of the mind whenever someone is talking about how does emissions fit in our production systems for beef. We're really part of a closed system. So if we're thinking about in beef, is there any better microphones? Or so if we think about beef production systems in terms of breeding programs, we often ask the question, what do we want to improve? And as part of our research, how good was that change? As part of our research, we try and think, well, what do we want to improve? For beef cattle, we could think in a per head system. We could think, okay, is it lifetime methane output from a cow grazing on pasture? Myself personally, I like to think of methane in a role of beef production, because we're essentially a food production system. So if we're producing food, we should think about how much methane are we producing per kilo of beef produced. Now, if we think of it in that sense, we can really start to close the system. We're producing food. It's somewhat like feed efficiency in a sense. How much of our inputs are we utilising? Are we more efficient in our food production? And so that resonates with me. Can we make food production more efficient by measuring methane, by including it in our breeding programs? Often another way of thinking about methane is to think, well, we've got a certain amount of feed to use, and are we being efficient at using that feed? And so we can express methane per unit of intake as well. But I really resonate with that middle one, per unit of beef produced, because we're a food producing industry. So if we're producing food and we want to do that more efficiently, there are many, many things that people can do to have an efficient system. And they're quite simple things for a production system. We can increase our daily weight gains so we have more efficient livestock production, so we can turn off animals earlier. That's a really good thing for the system. We can essentially reduce the number of dry cows. If we have high weaning percentages per unit of beef that we're actually producing, by improving weaning percentages, we become more efficient at using the feed in the system. We don't really have those freeloaders in our system anymore. That in turn reduces the number of replacement heifers required for the system. We keep our cows producing for a long period of time. Now, they're levers that people can pull already without a measure of methane in the system. So having a more efficient system is really good for efficient beef cattle production. And so I think it's really good to highlight that and to take that as a take-home message for today. Now, when we're thinking about our production system, and that's really the foundation for all science, is that the production system is soils, plants and livestock all together, not just thinking about one of them. We can really think about how can we improve methane, how can we manage it on farm. It's not just have the geneticist stand up the front and say you need a breeding value for methane. It's not just the nutritionist that says, don't worry about genetics, we've got it covered with feed additives. It's not just the soil scientist that says, don't listen to those guys with anything with animals, we can put it in the soil, so we'll save it there. It's actually everybody's message. So it's the geneticist, it's the nutritionist, it's the soil scientist all working together to come up with useful solutions to manage the whole production system. Now, of course, I'm an animal scientist, so I focus in this livestock space, and there are many different avenues of research that are occurring. So there's research into vaccines to try and actually minimise the number of methanogens in the rumen to actually reduce the amount of methane. There's feed additive research, there's genetics research that's happening all at once. But of course, I'll talk to you about the genetic stuff. Okay, so when we think about genetics, the big thing to remember is the world is about means and genetics is about variation. Okay, so whenever we're thinking about how much gain, what's the soil moisture profile, often we're thinking about what is the mean. But when we're geneticists, we think, what is the difference between all animals? And that's really the power of genetics. And so really our projects are around quantifying the differences between animals. Are there some animals that produce a low amount of methane, and are there others that produce high amounts of methane? And can we select the ones that produce low amounts naturally? So that's why we think of genetics. The other reason is that genetics change is small in a single year, but it's cumulative and permanent. So populations can essentially evolve in a short period of time, and we can make lots and lots of genetic change. I've got a couple of graphs here on the slide, and essentially they're the genetic change that the Angus breed has made since 2005. The average 600 day weight has gone up from plus 75 kilos to plus 120 kilos. So the amount of genetic progress they've made for growth has been actually very, very large. And many people in the audience would remember some Angus cows in the 60s and 70s being quite small and nuggety type animals to the cows of today that are much, much, much bigger. So genetic change is permanent, cumulative and long lasting, but we always have to plan for the future. We're always thinking, what do we need for the future? And that's why we're looking at methane now. So we have a project at the moment that's a collaboration between New South Wales DPIRD, UNE, Angus Australia and MLA to record methane on large groups of animals. And the aim of that project was to start to set up a pipeline for methane data to be used in breeding programs, to estimate breeding values, so the genetic merit of animals for methane, and essentially to try and help people select for more efficient beef cattle. Now, when we're talking about genetic tools, often we're talking about genomic tools. And genomic tools are underpinned by recording. So genomic tools are using DNA to predict the genetic merit of an animal. And to do that, we need to create a thing we call the reference population. Now, that reference population is essentially a group of animals that have been recorded in large groups for the trait and have also been genotyped with a genotypic test or a SNP chip. And so we record a large number of animals to provide tools to select animals in the breeding program. And now if we want to make really fast genetic progress, we don't wait until animals are 4 years old to select them. We actually want to do it at an early age so that we can use yearling bulls and we can join yearling heifers. So it's really important to utilise these genomic tools to have this early accurate selection. And essentially we're recording data to underpin those tools. Now for you, as many commercial producers in the room, what does that mean? That means that we try and have more accurate breeding value technologies for you to select bulls. Because really the quickest way to make genetic progress in a commercial system is to buy good bulls. So what we're trying to do is we're recording a couple of the national reference population projects. There's one called the Southern Multi-Breed Project, where we have 5 temperate breeds and 1 tropical breed as being recorded head to head. And we also have the Angus sire benchmarking steers that we record as well. Now that was all to underpin new technologies for genetic selection. Because what we want to do is be able to select animals at a young age across all systems, or as many systems as possible at least. Now, some might have the question of how do we go about measuring methane? The technologies utilised for measuring methane have changed over time, and I've got a few different pictures, so hopefully everyone can see. So the top picture here is chamber-based recording. So up at UNE, we have the largest chamber system for accurate recording of methane in the world. And what happens is essentially we get groups of cows and lock them in little boxes for a certain period of time, 24, 48 hours. And then we record all the emissions, whether it be methane or CO2 or those nitrogen-based emissions. And we also record how much feed is eaten, how much the animal changes in that 48 hours. So it's considered the most accurate short-term measure of methane, but it's only a window, 24 to 48 hours. Then we have some what we call sniffer technologies. These are essentially a methane sensor that can be put in any machine somewhere. Now these are much less accurate than our chamber-based systems, but they can give you an idea of some rankings between animals rather than absolute values of methane. At the top, we also have portable accumulation chambers. This is a blown-up version that's utilised in New Zealand. It's essentially trying to mimic our chamber-based systems, but in short term, 25 to 40 minutes. You put the animal in and get a single short record. Now that's okay to try and help us rank animals for genetic genetic technologies, it's not very good to validate feed types or supplements for emissions. Now down the bottom we have two technologies. One is, you might have seen the backpack being put on animals. It uses a tracer technology to measure how much methane an animal is belching out. You've got to remember they burp, they don't really fart. So belching out over when they're recording on pasture. The reason it was developed was you can't really put a pasture-based diet in these systems. It was to try and get an accurate measure on pasture. One of the challenges with that system is that it uses a tracer, SF6, that's also a really bad gas for the environment. So it's very, very rare. It's more utilised in treatment-based experiments, not genetics experiments. Then down the bottom, we have a green feed machine. It's essentially a spot measure of methane that's taken throughout the day, and that's what we utilise in our project. So if we think about the green feed machine, what it does is essentially have multiple spot measures of an animal attending a feeder over time. Now, often one of the biggest questions people ask is that similar when an animal's going in taking a snack from a feeder? Is methane produced at the same rate while they're eating as it is when they're sitting down having a rest or when they're not eating? The thing about methane when an animal is belching is there's a continual amount of methane that's being belched all the time. As long as the animal is breathing, there's methane that is being released. That's a challenge for if you wanted to record animals when they're drinking. Because let's play a little game. When you're eating, you're like, and you're breathing, okay? Everyone breathes when they eat. When you drink, hang on, what do you have to do? It's not so good for your lungs if you're breathing when you drink, is it? Okay, so when we have systems, the reason they've been used for feeding-based systems is you still breathe, and cows do too. And that methane is released while they're breathing and eating at the same time. But it's much, much more challenging to breathe when you drink. So all the systems that are being developed now really are linked to these spot feeding systems. We can record it in two different situations, whether it be in the feedlot or whether it be in the pasture. And that's why we chose the green feed system, because we essentially record in both systems. Up at Talimba, some of you may have been to our efficient beef updates, and also on the New South Wales deep herd farms around New South Wales at 5 different locations. So where are we up to? The project is actually a 4-year project, and we're 2.5 years through the project. We essentially record 1,350 steers at Talimba for methane, and around 750 to, it's actually a few more now, to 900 on the New South Wales DPI farms in the Southern Multibreed Project. And we've been doing that for 2.5 years. We've got 1.5 years to go with that recording. So what does our recording look like? We run the animals through in cohorts. They're big contemporary groups, we call them, where there's variation in animal performance across that contemporary group. One of the challenges with the green feed recording equipment is that it's a voluntary recording. So animals have to choose to go to the feeder. And not all animals do choose to go to the feeder. We have 70 to 90% of animals that go to the feeder, so still high usage, but it is one of the challenges that we have to deal with. So over the last few years, we've got almost 4,000 records, and 22 to 2,500 of those come from the feedlot. Sorry. Of the breeds that we've recorded, there is a large proportion of Angus animals because we record their sire benchmarking project, and they're also a key link breed for Southern Multibreed. They're across all sites. But we also have our Charolais, Hereford, Shorthorn and Wagyu. The reason we have those breeds is at the commencement of the project, they were the 5 largest breeds for the number of bulls sold in the country for temperate breeds. So essentially it went Angus to the others in the number of bulls. That's essentially why they were chosen, based on their footprint in the industry. Now, looking back on that, I often get questions about other breeds, because there are plenty of other breeds of beef cattle in the systems that may have useful performance for a trait like methane. So I would like to think in the future that there may be opportunities to test some of those, because just because we have a temperate system that is dominated by Angus cattle doesn't mean that other breeds won't be useful for traits like methane. I collaborate heavily with other countries' research organisations, and say a place like Ireland, where they have a very different production system, other breeds actually are showing quite a lot of a reduction in methane. Think at breeds that are more European than the British type breeds. So it'd be nice in the future to think, how can we accommodate more breeds going forward? Or go to people's farms to record their animals rather than having centralised reference populations. So what are the lessons from the feedlot? Just to make it awkward. So the lessons from the feedlot are that it's really important to have enough of our machines in a feedlot pen to ensure we record as many animals as possible. If you have group sizes that are too large and not enough feeders, you essentially, I've said essentially a lot, but you get behaviour changes in the feedlot. Bullies come in and say, no, you're not allowed to get recorded because I like going there. Whereas if you have enough feeders, you can manage that behaviour. We also really have to make sure we monitor feeders every day. Every morning we make sure that we have some software that says, is that machine working? Have there been a lot of records? Are the animals still going to that machine? Do we have to intervene and start to try and encourage animals to go more? On pasture, we've had more challenges at getting a large number of records per group, which actually makes sense because cows can choose to be in a nice green paddock, or they can choose to go to a confined feeder. And if they're not trained well to go to a feeder, they actually don't go to it. So over the lifetime of the project, you notice that for our STU, which is the progression in the project, we've got a lot better at recording methane on pasture because we've trained animals to attend those feeders. Whereas at the start of the project, we didn't quite know that as much. So we've learnt and evolved in that system. And we only record the multi-breed animals, so there's not as much of a dominance of the Angus breed in those heifer systems. So the real lessons from the recording on pasture is you really have to train animals to make sure they actually go to the machines. Otherwise, you just don't get a record. And if there's an exciting place to be, like some nice grass and a nice tree somewhere else, cattle often choose not to go to the feeder. So if it's a drier system, you get more attendance than you do if it's a really lush system. The choice of where we put the machines is important too. If you choose to put them where all animals go, like going to water, or if there's a favourite hangout spot to camp and ruminate, then you get more records as well. Here's just a quick video of that's been given to us by New South Wales DPI, so collaborator Tom Granleys took a bit of a timestamp photo. You can see animals come in, they wait their turn, get recorded over the time. So if we show that again, we get lots of different animals coming through the day to get recorded. Essentially, take their bait, breathe in the machine for 2 to 3 minutes, and give us a measure of methane. When we monitor the machines, you can see that some days the machine stops working. That's with our heat map. See this line? Actually, machines stop working. And if we don't monitor it and work with staff that are managing the machines, then we often miss days of records. And so one of my colleagues is postdoc here. If you get to talk to Meta Madsen, is in the crowd, in the back, if she can put her hand up, has done a lot of the work that's around the monitoring of the machines, as well as the analysis of the data that we see. So let's have a quick sneak peek of some of that data analysis that Meta has done. So of course, not all data is clean, so we have to do some cleaning, and we have to make sure we have good quality records over our trial period. We have to throw some of the ones out that we say are a bit outside the realms of normality. But then we can estimate kind of how much does a cow produce. So we can see our means. If we have a look, the point's not working. So our means for our feedlot system and our means for our pasture systems. Well, we made a decision at the start of the project to make sure that the feed that was on offer in the feedlot was not a really hot ration. It's not a high grain ration. It's around 65% grain. So it still has a lot of roughage in the system. Because if you have a high grain ration, you do expect to have lower methane emissions. And we wanted to more mimic high performance pasture systems. And I think we've done a reasonable job at that, to make sure that the two essentially rations on offer relate to each other. One thing about the pasture system is no two paddocks are the same, no 2 years are the same. Sometimes we have drought. So we've been recording down at Yenko and it's been extremely dry. And so that record in that pasture system is very different to Trangie, which has had a wonderful season, and we have oat crops this high. And we've recorded animals on those oat crops. So we have this really diverse system in the pasture, whereas a really controlled system in the feedlot. And that can be quite tricky to model when we're thinking what is that methane outputs in those systems. You can see also that we've tried to test a lot of animals with these are the animals that have been put in front of the feeders, and what we're actually getting records for is a little bit less than that because of that choosing to go to the feeder. When we're thinking of genetics, we like to know what variation exists in the population. And so if we just have a quick look at the plot here, think of it as how much variability there is in the population. Because animals are growing a lot in the feedlot, we tend to see more variation in that system than we do in the pasture system, where they're at more of a maintenance level. So that growth and maintenance of the steers when they come into the feedlot is quite different to what we see in the pasture. What's a good thing though, up to the top left, there's a number there, 0.58. In new analysis around that 0.5 as well, that there's a positive correlation, so there's a positive relationship between the cows that are the records on pasture and the records in the feedlot. What we were worried about is that they'd be completely different. Wouldn't that be a big worry, that it's completely different? It's absolute that, if we record in the feedlot, it doesn't help us on the pasture, or vice versa. But what's really exciting is that if you record in either system or in both systems, you can actually go in the same direction. The ones that are low emitting in the feedlot are also the ones that are low emitting on pasture. So we've estimated research breeding values from the data that we've collected, and we often get asked, what's the relationship with something like growth? Are animals that grow faster more methane efficient? Well, actually, animals that grow faster have to use more feed, so they do actually, on average, have to produce more methane. But the nice part is that there's lots and lots of animals that grow fast, but also produce a low amount of methane. And that's what a breeding value or a measure for methane helps you do, is find these animals in the green. Often also get asked, what about feed intake? And I've done a lot of feed efficiency research. And so one of the goals behind the project was to see, well, what's the link between feed intake and methane? And like we expect, animals that eat less also produce less methane. And so feed efficiency is actually a really good way of trying to reduce methane as well. So what have been the challenges and what's the future? We're getting close to the end. So the challenges and the future. Hopefully not the end of everything, but close to the end of the talk. So what we want to do is keep continuing recording to make sure that we have accurate genetic tools. There are future projects. We have a involvement in a large CRC, Cooperative Research Centre for Zero Net Emissions in Agriculture, where we're continuing to develop the tools for genetic selection. It's really important for the whole production system to not be narrow and only focus on methane. It's really important to record lots and lots and lots of other performance traits too, whether it be birth weight, whether it be growth, whether it be carcass traits, or female fertility-based traits, so that we end up with tools that are useful for the whole production system. We then need to work out what's the best way to select for methane. Is it to include it in a selection index, similar to what happens in other breeds, or like Angus or breed plan-based genetic evaluations? Or are there other ways we can do it? Can we use our genomic tools to just find those green dot animals and utilise it that way? We also, as scientists, have lots of other questions about the biology of what happens to a cow if we select for lower methane. So as part of the project, we've taken a lot of other samples as well from the rumen, because that's where methane is produced, to understand, are there other things that we're influencing? Are we influencing the other gases that are produced during digestion? We call them volatile fatty acids. Are we changing the microbiome structure in the rumen, the population? Is it changing a lot? Is it impacted by protozoa? All of that information is kind of secondary to our methane research, but it helps us understand what's happening in terms of the biology of the cow. And of course, we've got lots of future projects as scientists. We're always looking for further collaborations to record on breeders' farms. And so there's going to be more of a focus in the future about, instead of just recording in research farms like we've been doing, which has been really useful to date, there'll be opportunities to record in breeder farms too. And of course, I've presented a large body of work, and it's not all my work. It's a huge group of people that work in the space. And I'd just like to acknowledge the funders of the project, with New South Wales DPI being a really big proportion of the project, MLA, Angus Australia, AGBU, which is a research unit up at UNE, and the university itself. And thanks very much for having me today. That's a really good question. So just to repeat the question is, how, in terms of probiotics, how does the ban on rumensin, which is a common feed additive in most rations that are used within the feedlot, and even on farm finisher rations and pellets, often have rumensin or momensin in them. So rumensin does reduce methane, and there's a lot of early feed efficiency work that showed that. In terms of utilising, markets are a tricky thing. And so the EU is probably the trickiest market. In terms of probiotics, there still needs to be a registration process. So I can't say, oh, you could use it or you can't use it, because the market determines that. What often happens for markets, though, is if you can't go to one market, there's other markets that you can send beef to. And so it ends up being other markets that will get sent to. And there'll be different levers that we have to pull for the EU.
G'day, Craig. G'day, Craig Hunt. Very early in the presentation, you were talking about the way that we can develop our herd genetically, so we're talking right to your pet subject, to be reducing our methane production. So it's a question with a slight technicality in it. The smaller, more fertile cow with early breeding capability, you were talking about joining yearling heifers, and I'm part of a WhatsApp group that are very interested in this sort of stuff, and we have what we call a 2-3 cow. So a 2-3 cow calves at 2, first baby is born her first, second birthday, and then has another one on the third, because if she does that, she's going to keep calving. The sire in my 2-3 cows is out of a 14-year-old cow who had her 15th calf when I bought him. And he's the only bull I bought, basically. So is that going to reduce, you know, we're talking cattle that are 450 to 550 kilos rather than, I bought some store cows the other day and there was a store Angus cow of 710. Far too feed efficient, inefficient, and came out of wet country.
Yeah, so it's a really good question. Maybe I'll summarise it a little. In a sense, what's the role of a small efficient cow versus a large cow that may have the same amount of calves, but it's really this cow size and cow weight discussion. Is that a fair way to put it?
Are they as efficient first?
Yeah, so if you put it in production system ways, smaller cows have lower maintenance and they have to be there for a long period of time. So there's often been a lot of discussion around how we value cow weight in a production system, because also the major revenue stream for most systems is essentially selling kilos of a cow. Now, if you want fast growth, often that's correlated with bigger cows. And so if you select cows early that have bulls that are fast growing, you often get bigger cows. So that's a real challenge. The way to make sure you get smaller cows and also having lots of calves, and this is going to sound like I'm a geneticist, you have to measure stuff. Okay, so the culture in most breeding programs is to measure early stuff, select your bulls, sell them, and not actually record things like cow size, things like how many calves are those cows having. So it's really important that people start to measure that and buy bulls from places that actually measure that. Because if you don't measure it, you're essentially walking in the dark. You don't really know where you're going. You don't know if you're going to get big cows or small cows. If you just buy the biggest, shiniest bull at the next sale, it's unlikely that you're going to have small cows that are efficient. So go to places that measure it and continue to measure it and work on having tools that allow you to moderate mature size, as well as having lots of calves, because that's a really